to write a good summary, we have to read the problem very carefully from the beginning to the end. Then we will search for 3 different kinds of information. If you have a chemical reaction, the balanced chemical equation will be the first kind of information you need to write down. Then you will search for numbers with units. The last kind of information you need to write down is what we're looking for. What we're looking for is also very, very important in your summary. Because if you don't know what you're looking for, how can you get even started? Well, for this particular problem, we do have a balanced chemical equation. Therefore, I'm going to copy it down first. Now let's search for numbers with units. When we write down the numbers with units, make sure you put them down into the proper places. What I mean is, these 2 numbers with units are the information for oxygen gas. Therefore, in my summary, I have to write down both of them under oxygen gas, below the balanced chemical equation. I cannot put it down somewhere else. Then, let's try to write down what we're looking for. We're looking for the grams of potassium permanganate. Therefore, I have to put down the question mark below potassium permanganate under the chemical equation. I cannot put down the question mark somewhere else. Well, this is the summary of our problem. In my summary, I assign a symbol to every number with a unit and what we're looking for. Because all equations contain symbols, not numbers. If we can assign appropriate symbols to the numbers with units and what we're looking for, it will be easier for us to find the equation to use. Well, from our summary, can we tell, is this a stoichiometry calculation problem, or stoichiometry is part of our solution? Well, actually, it is. Do you see a Greek letter pi? Here it is. Not pretty enough? Let me give you a prettier pie. Want a real pie? Here it is. Sorry, it's a fake pie. You cannot eat. If you see a Greek letter pi in your summary, horizontal line, 2 vertical lines, stoichiometry is part of your solution. For stoichiometry calculations, we will know the information of one chemical. If it is in moles or grams, we are looking for the grams or moles of another chemical. This will be the standard stoichiometry calculation problem we learned in class. However, in some problems like this one, we are not given the mass or moles of one chemical. But from what we are given, we can convert the information to the mass or the moles of the chemical. Then, stoichiometry is part of our solution. In this particular case, we know the density, we know the volume. From chapter 1, we know we can calculate the mass in grams for oxygen gas. Then, it will turn into a standard stoichiometry calculation problem. Once we get the mass in grams of oxygen gas, we can convert the mass in grams of oxygen gas into moles of oxygen gas by using molecular weight of oxygen gas. The next step is we use the stoichiometric ratio of the balanced chemical equation to convert the moles of oxygen gas into moles of potassium permanganate. This step is called stoichiometry. The reason I put on the chemical formula behind the unit mole is because we have 2 different chemicals at least. Without the chemical formula, it's very hard to tell them apart. Which one is for potassium permanganate? Which one is for oxygen gas? With the chemical formula, this will be very, very easy. If you're looking for moles of potassium permanganate, we will be done. However, we're looking for the mass in grams of potassium permanganate. Again, if you remember, we can use the molecular weight to do the conversion. Well, it seems from our analysis, it is possible to find the solution for this problem. Let me emphasize, how do you tell a problem is a stoichiometry calculation problem, or stoichiometry is part of your solution from the summary? Well, if you're given the information of one chemical, from the information you can get the mass or the moles of that chemical. You're looking for the information of another chemical, and both chemicals are related by the balanced chemical equation. Pretty much, stoichiometry has to be part of your solution. You're given the information of one chemical. You're looking for the information of another chemical that is linked by the balanced chemical equation. That's stoichiometry, or stoichiometry is part of your solution. Now let me label the steps. Step 1, Step 2, Step 3, Step 4, Step 5, Step 6. Well, in its genuine sense, only Step 4 is called stoichiometry. But it doesn't matter. Most of the problems will look like this one. It's not a single step conversion. You have to do multiple step calculations. Now let me show you the work of all steps. Well, we're done.